Hello, 8Es, receiving teachers and students. Thank you, you may sit down. All right, 8Es and receiving students. Now, in our previous lesson, we didn't have correction from one of our groups. That was group E, was it? All right, so we're going to have that group now to correct or to present their answer. And I'm sure that was on question number 5. All right, question number 5. Receiving students, if you can recall our previous lesson on weight charts. And question number 5, we didn't correct that. So we asked that group to give us the answer in today's lesson. So can we have that group now to please present or give us the answer? Thank you. Can you read out the question, please, and then the answer?
Our question is question 5, and it reads, can you describe the growth progress of the child during the first year?
Our answer was our description was the progress of the baby for the first year was very slow, meaning it didn't gain a lot of weight from month to month.
Okay. Thank you, group E, that group. All right, good. Now, we're going to move on to today's lesson, which is on weight and volume. Okay, receiving teachers and students, weight and volume, our topic for today. Now, can someone name this solid shape? Receiving students, 8Es. Name this solid shape, please. Okay, this is a solid shape, right? What is this shape called? What is this solid shape called? Receiving students? Yes? All right, Peter, thank you.
Rectangular prism.
Very good. Rectangular prism. What else can we call this shape? Is there any other name given to this type of shape, solid shape? Okay, good. Peter said rectangular prism. What else can we call this? Yes, Eddie?
Void.
Cuboid, very good. So we can say a rectangular prism or a cuboid. Now I want to find the volume of this shape, this cuboid, all right, this cuboid or this rectangular prism. How am I going to find the volume of this? Or what formula will I use to find the volume of this shape, this cuboid? Quickly, receiving students. Silas?
Area times height.
Area times height. You others agree with Silas? I want to find the volume of this cuboid. Okay, good, Silas. But when we want to find the volume of a cuboid, what formula do we use? Volume? Now I'm giving you a hint. Volume? Okay, area times height, yes. Or we can say volume equals length times width times height. Okay, good. So you can have those formulas. Volume equals length times width times height, or volume equals area times height. Okay, good. Now I want someone, 2 students, to come up to the front and find the volume, okay, of this shape here, this cuboid. Now I have a ruler here, and using the formula volume equals length times width times height, you're going to come up here and measure the length, the width, and the height. And then you will come up with the volume of this cuboid. Okay, let's have 2 students, please. So make sure when you're reading you get your measurement, make sure that the receiving students must also know the measurements. Okay, quickly, let's have Norris or Loris, please. Okay, let's have Loris and Hetiba. Okay. Can both of you come up, please? Now. Okay, you're going to get, this is the length, right? From this side. So, get your ruler. Start from 0. Yes, you can do that, or you can come this way. Okay. All right. You get the mic, and or you can write it up there, the length. Okay, it's 44. Okay, get whiteboard over marker over there. Okay. All right. Okay, that's the length, the width. Get the width. Okay, this is the width. Okay, is it just 44? 44 what? Okay. Okay, Mandy, you just move up like this. Okay, starting from 0. 20. Okay, good. Now the height. The height, which should be the height? This one. Okay, good. Okay. Starting from 0. 36, good. Okay, can someone help please to calculate, receiving students, just calculate the volume. Okay, the measurements given, length is 44 centimeters, the width is 20 centimeters, now the height is 36 centimeters. Now, receiving students, can you just help to calculate the volume of this cuboid here? Okay, thank you, Tools. You can then sit down. All right, anyone got an answer? First one to give us the answer, the correct answer. Receiving students? Okay. Group A is still working, Group B, Group C, D, and E, not yet. They haven't got an answer. Which group will be the first group to give us the answer? Okay, good. Group D.
31,680 cubic centimeter.
All right, that's the answer. You others agree with the answer? Yes? Okay, very good. 31,680 cubic centimeters. All right? So the volume of that shape, the volume of this cuboid is 31,680 cubic centimeters. Now, the next question is, I want to find the volume of this shape in liters. All right, 80s and receiving students. I want to find the volume of this cuboid in liters. Does anyone give us an answer? Or to find the volume in liters? All right. Would like to give us the answer, please? All right, let's have. All right, Alfred.
31.68 liters.
31.68 liters. What about you others? You also agree? 31.68 liters? All right, who can tell me how you got your answer? How did you get 31.68 liters? How did you get, receiving students, how did you get 31.68 liters? If you say that the volume of that shape, of that cuboid, is 31.68 liters, then what did you do to get 31.68 liters? All right, we'll have, okay, this group here to give us the reason or how they got 31.68 liters.
How we got our answer? 31.68 liters is 1,000 cubic centimeters is equals to 1 liter. So we divided by 1,000 and we got 31.68 liters.
Okay, 80s and receiving students, did you get that? All right, 1,000 cubic centimeters in 1 liter is equal to 1 liter, or 1 liter is equal to 1,000 cubic centimeters. Therefore, we got, because the 31,600 cubic centimeters, all right? If it's in liters, we get 31.68 liters. All right, 80s and receiving students. Okay, so the volume of this cuboid here is, in liters, is 31.68 liters. Right, 80s and receiving students. But the volume in cubic centimeters is 31,680 cubic centimeters. Okay, still, now we move away from liters, and this time let's look at, if I pour water, right, into this cuboid, right? Let's just say if water is poured into this cuboid, okay? This time I want to ask the weight. What will be the weight of this cuboid in kilograms? Okay, 80s and receiving students. Now I want to find the weight of the water, all right, in this cuboid here. What will be the weight of this cuboid in kilograms? Okay. Now I'd like you to just please, in your groups, I want you to discuss. Remember your conversions from your previous lessons, grade 7. I'm sure you looked at conversions of weight, okay? Liters. All right, the question is, what is the weight? What will be the weight of this cuboid in kilograms? Okay. Who's got an answer? Okay, have you got an answer? All right, let's have this group here, group C, please. Can you give us your answer?
31.68 68 kg.
31.68 kilograms. You agree with the answer? Very good. Okay. Now, later I'll show you how we got our answer, okay? The working out of 31.68 kilograms. All right, if it's, let's say, what will be the weight in, this time, what will be the weight in grams? 8 is? Receiving students? Okay, you said 31.68 kilograms. Now, what will be the weight in grams? What will be the weight in grams? Receiving students, 80s. Again, you try and do your working out. Okay. All right. Okay, group D. You're going to give us your answer. Okay, what will be the weight in grams?
31,680 grams.
You others agree? Yes. Okay, very good. 31,680 grams. Now, in tons, what will be the weight of this cuboid if water is filled in tons? Okay. Okay. Let's got an answer. But you have 31.68 kilograms. 31,680 grams. All right. Okay, we're having all the answers coming from group D. Okay. Can you give us your answer, please? In tons. What is your answer in tons?
$31,680 tons.
31. Okay, thank you, Eddie. They say 31,680 tons. Do you agree with Eddie's answer, receiving students? Now remember we said in grams, the weight of this cuboid in grams is 31,680 grams. So you are saying 31,680 tons. Come on. Okay, let's try and, okay, if you cannot, we'll try and work it out here. I'll show you how to do the working out. All right? Okay, let me just take this one out first. Later I'll explain. All right. Okay, let's say how many grams or how many kilograms is equal to 1 ton? Okay, 1,000 kilograms is equal to 1 ton. All right? This is one way of working it out. Now, how many kilograms are there? 31.68 kilograms. 31.68 kilograms. Now, what do we want to do? We want to change it into tons. So, this is X. We don't know, unknown. Right? 1,000 kilograms is equal to 1 ton. Right? Is 1 ton equals 31.68 kilograms X. So, what we're going to do now is, this is one way of working it out. We're going to get the multiple of the exterior. This is the exterior. This one's the outside, okay? And the multiples of the interior. Exterior and interior, okay? So 1,000 with this one is 1,000 what? X, yes? Okay, 1,000 times this is 1,000 X equals to this one, 31.68 times this is 31.68. Okay, now what do we do now? Divide. Divide by 1,000 because we want to get rid of the, 1,000 to have X. Okay, I hope I'm correct. So what do we do here? Decimal point to the what? Left. How many times? 3 times. 1, 2, 3. So our answer will be 0.03168 tons. Okay? Did some of you get this answer? Stop lying. Okay? Okay, X is equal to 31. I mean, you nearly got this answer, but so one way of working it out, this is, you can follow this not formula, but you can follow this step here. Getting the multiple of the exterior and multiple of interior. Okay? Now that's the same with the other conversions there. So you can, X equals to 0.03168 tons. Okay, 80s and receiving students, this is what we're going to do. Your activity, I'm going to tell you to do that for your homework, all right? You will do that for your homework, receiving students. Can I have you to just copy this work down, please? Just copy down this work, and I want you to do it for your homework, all right? Receiving students, please, can you copy this one down quickly into your notebook, and then you can do it for homework. All right. Number 1, it reads, find the volume of the cuboid. Okay, you find the volume in cubic centimeters and in cubic meters. Okay, that's number 1. Now let's move on to the next one, number 2. You can copy from your friends, thank you. Number 2, okay, again, if water is filled into that cuboid, What will be the weight in kilograms? Okay, quickly. Okay, good. You finish? Yes. All right. Okay, that question is for that diagram. Goes with the diagram. What is the volume of the pool in cubic meters, in liters? Okay. Finished? Okay, good. All right. We'll stop here. And in our next lesson, we'll go through this topic again, weight and volume, all right? So you can really understand what is weight and what is volume and how to convert weight and volume measurements, okay? So I don't want you to get worried because, let's say, if you didn't understand anything from this topic, because we look at it in our next lesson. Okay, thank you, class. Our key phrase for today's lesson is on weight and volume. Okay, thank you, ATs and receiving students, for participating in today's lesson.